It is a klystron power supply. It is a klystron mount and it is isolator. It is a variable frequency meter. It is a variable attenuator. It is a slotted line session and it is a slotted tuner or SS tuner. It is SS tuner, and the last one is a matched load, and we may connect a matched termination also at the end, and we may connect a detector mount also by replacing this matched termination. So by this connection of detector mount, we can take the output directly at this point itself. And one more device is fixed attenuator, and it is a fixed attenuator device. It consists a fixed resistive cord inside it. Depending upon the resistive area of the cord, the resistance of the device will be fixed, and it is a 6 dB resistance offered. 6 dB resistance offered by this fixed attenuator. And we are having variable attenuators which we seen here, and it is having a variable resistive cord inside it, that will be moved up and down. So we call this one is known to be flappy type variable resistance or attenuator, and this is used for different attenuation levels, and it will be the fixed one. So both the difference between a fixed one to variable attenuator is the resistive cord is moving in the variable attenuator, and it will be fixed in a fixed attenuator. Circulator, actually we have seen the same device at the starting stage known to be isolator, but it can be work for circulator itself. So once you close the one port of circulator like this, then it can work for isolator. If you remove this point and it can work for the circulator. And one more device is known to be multi-hole direction coupler, and it is having 4 ports actually: port 1, port 2, port 3 and port 4. And in these 4 ports, 3 ports are open and one port is a closed one. We are using this device for knowing the different power deviations from one port to another port. Once you connect port 1, and what we can identify the output power levels in port 1 and port 2 as well as port 4 also by using this detector mount. We connect a detector mount at what point you want to know the power, and we close the unwanted port with the matched termination like this. We have a matched terminations. So these matched terminations will be connected at the port where we doesn't want power itself. So in micro bench operation, the first step is to switch on the klystron power supply power button, that is this one. So once we switch on the power button on back side, we have a display like this. After that, we have to switch on the high tension power button, this one. So once we switch on the power button, we can have a display of 199 to 200 volts on beam voltage and some current here. So we have to fix to operate the klystron power supply. We have to operate the beam voltage nearby 300 volts. So we have to change this voltage to 300 volt by the beam voltage knob. So just slightly, gently move the knob and vary the voltage up to 300 volts. So just put 290 itself. So it's a maximum voltage that we have to operate, 300. So we may stop at nearby 290 itself. So after putting beam voltage, we need to change the repeller voltage. So that is the repeller voltage. We have 2 knobs are there for variation of repeller voltage. One is fine one and one is a coarse one. So the fine one, so this is a fine one. So once we change the fine one voltage, and we have a variations of very small variations nearby 1 to 2 voltage itself. So by changing the total knob, we have a deflection voltage of 7 to 8 only. Now we have to change this course, then we may get the larger variations that can be observed on the display one. So we can have different voltages for this repeller voltage itself. So these can be varied from 0 to nearby 200 volts, nearby 290 or 270 volts. Now we have to put the some other knobs known to be modulation knob. So we can put the modulation knob in CW mode or amplitude mode. So CW stands for continuous wave mode, and AM for amplitude mode, and FM stands for frequency mode, and last one is external mode. So just put the mode in a amplitude mode only, then you can get the better outputs on the results for the operation of this 300 volts klystron power supply. So once you put the amplitude mode knob, modulation knob in amplitude mode, then you have to change the amplitude mode, amplitude and frequency knobs to some other extent, which can produce some accurate output at the CRO. So now if you place the modulation knob in FM mode, then you have to adjust the amplitude and frequencies by these knobs to have a better output at the end of the CRO or VSWR meter. Now let me tell how to switch off this klystron power supply. Now just we started from the back side. Now we have to go from the last step to back step. So firstly we have to stop these amplitudes to down level. So we need to reduce this to fully anti-clockwise direction, and we need to cut down this modulation knob, and thereafter we need to reduce this repeller voltage to down value. After that we have to stop this beam voltage to its last value. So you can check it. So we can get the last seen values 192 and some current here, and after that we need to switch off this HT button so that we have a 0 voltages. So this display must be 0 volt, either in voltage or current. It should show 0 voltages on the display, then only you have to switch off the last power button, then only this klystron power supply will be safe, otherwise it may damage. So now if you operate the beam voltage and the repeller voltage to some particular values, then we can generate this klystron mount will generate the microwave signals. It is a very heating one, so we have to use cooling fan for cooling this klystron mount, and the signals which are generated by this klystron mount will be guided to the next level known to be isolator, and this isolator is device that guides the microwave signal to the next level, and the signals which are from isolator are forwarded to the variable frequency meter, and this variable frequency meter will use it to identify the frequency signals that are generated by this klystron mount. So this is a variable frequency meter, and this variable frequency meter is used to identify the frequency signals that are generated by this klystron mount. So how to find out the frequency by this variable frequency meter is that it consisting two red lines, two horizontal red lines and one vertical red line. These horizontal red lines are movable. Once you change this, once you rotate the knob of frequency meter, then it will move up to down. So while you are moving up to down, then at a particular situation we have a notch, or we can have a reduction of output voltage on the CRO. So once we vary this variable frequency meter, then the output in CRO will dip once at a particular point. At the dip point we have to stop the variable frequency meter variations. So let me take at the point of this 9.84 is the value where you are getting dip on the CRO. Then the signal which is flowing in this bench is 9.84 gigahertz range frequency. So once you have some other frequency range here it is between 9.86 to 9.88. so the in between value is 9.87 is a frequency that is going, gigahertz frequency is going on the microwave bench. So we have to consider the signal value is between these two horizontal red lines, which is matching with the vertical red line. The next component that we are having in microwave bench is variable attenuator. So this variable attenuator is a device is used to stop the signal that flows in the microwave bench. How much of signal we have to stop or we have to allow will depends on this variable attenuator value. So it consisting a variable knob like this. So it is a variable attenuator and it is consisting a movable scale on this one, and we have a fixed scale on the variable attenuator. So we can see the numbers 0, 5, 0, 5, 10, 15 up to 25. We have the numbers on the fixed scale, and we have a rotating scale will also consist of 0 to 50, 45, nothing but 50 numbers will be seen on the mobile one. So once you have to fix a dB of 25, then just put a 0 dB, put the line on 25 which is matching with the 0. So it is a 0 line crossing the 25. So it is a 25 dB attenuation will be offered by the device at this point. So the resistive chord will be 0. There is no resistive chord. Once you see that there is no resistive chord, 25 dB attenuation, there is no resistive chord. Once you have to you are increasing the dB value. You are increasing the dB value by rotating this knob. So we may see that variable resistive chord is moving into the slotted line. Once you you are seeing that we are getting that resistive chord into the line. So that is a resistive chord which stops the signal that is flowing in the microwave waveguide. And the next component is slotted line, and it consists one fixed scale. This one 6 to 19 scale is a fixed scale, and we have one more scale, variable scale or movable scale, which is moves on the fixed scale by a slotted section. This is a slotted section or slotted line that we are having on the microwave guide. And we have a wire or conductor for this slotted section or slotted tuner, and which moves on the microwave guide. It can be adjustable by using this SS knob or SS tuner. Now, so while doing experiments, we move this movable scale on a variable scale so that we can find out the D1, D2s which are useful to identify different parameters in the microwave bench setup. So we have D1, D2s. D1 is a maximum lambda value that will be observed at maximum peak. So once we move this variable or movable slot, then we have a maximum output on the CRO. At that particular time, we have to stop this variable or movable scale, and at that point we have a matching of this scale. There are number of digits are there, so this will maximum one value will exactly match with the fixed scale, and we have to note down that value as a D1. So that is a maximum value that you can have for the output. And now we have to move this again to know the D2 value. So in a practical value, we have two values, D1 and D2. D1, D2 is to identify the lambda value, that is a wavelength value. The wavelength is a value that comes between two successive maximums or two successive minimums. So we have to find it out the D1, D2s between two successive maximums or two successive minimums. Now we have to check the maximum value. Once we move this scale on this one, then we can get a maximum value. Then we note down the D1, and we move in forward direction or backward direction again, and we get the maximum value on the CRO. So that at point also we can note down the D2. So D1, D2 or D1, whatever it may be. So we can find out the difference between these twos. That length is the wavelength for the signal that we are having. And this D1, D2's difference is a lambda value, wavelength value, and it will be useful for different parameters identification. And the last one is the detector mount or matched termination one, and it is used. We can replace this matched termination with a detector mount, and this detector mount consists plunger at the end, and this detector mount is functions the same function that the slotted line is having, and we can connect the output we can connect output terminal to this one, so we can see the output signal on the CRO by this detector mount.